Okay, so now we're getting into reactions where it can be a little tougher. It involves some more balancing and some more thinking because you've got more than two reactants involved or more than two products involved. So we have single replacement here. Now, single replacement is, again, exactly what the title sounds like. You've got, say you've got A, B as your compound, and then you've got C as well. This is your reactants, things going into a reaction. And then that's going to produce, you've got one that's going to swap out. Okay? Now, it's important to remember that if this is a metal, so it is going to have a positive ionic charge. If you think of like magnesium, right? Magnesium is either magnesium solid or it's 2+, right? So that's a metal. Then it has to take the place of the metal. And if this was, say, a halogen or something like Cl, or it can be Cl minus, then, if this is a metal and this is a metal, then it's going to take the metal's place. If this is a non-metal, this is a non-metal, it'll take the non-metal's place. Do you know what I mean? It's going to replace the most similar thing. So if it's, Cl here where B is and F here, you can imagine that because they're both nonmetals, F is going to take the place of Cl. So let's look at, say these are both nonmetals. Then you'd end up with AC plus B. This is your general formula, right? Now, on the other hand, if C was a metal, like A is a metal, then you'd end up with Cb plus A. It sounds kind of weird in general form, but it's really intuitive and easy to understand when you think of examples. So let's look at an example. So you've got your A would be Cu, that's a metal, right? Copper. And then you've got Cl2, because copper's combining capacity is 2+ for copper. Okay? And Cl's is just 1-. Too many arrows going on. But that makes sense, right? So you've got CuCl2, and then your other reactant here is zinc. Zinc can come in regular zinc or 2+ as well, just like copper. And so this is going to be a nice easy swap. Which one do you think it's going to go into? Okay, you've got a metal and a non-metal and a metal here. So the metal is going to replace the metal, because they replace the ones they are most similar to. So you're going to end up with ZnCl2, and copper is going to come out of the compound and be on its own. So it's pretty simple. It's just if you've got a metal as your kind of third wheel here, then it's going to replace the metal, and if you've got a non-metal, it's going to replace the non-metal. Really, really simple and straightforward. They replace the ones they're most similar to. Okay. We can look at kind of another example here, just for fun. Woot woot. If we have Mg, magnesium, and HCl, which is hydrochloric acid, as you should know, then what's going to happen is Mg is going to take the place of the metal. Hydrogen, of course, not always a metal, but it can act as one. It can be H+. So Mg is going to take that place. MgCl2. You see that now has to be 2 because we're balancing, because there's 2 Cl's on this side too. We'll go over that more later with balancing and Roman numerals and stuff. And then plus H2, because now we have this diatomic, 2 H's here. That balances out nicely. Okay, so in this situation, it was again a metal taking the spot of a metal. I'm going to do one that's not that case. So we've got NaBr. Which one's our metal here? Sodium. And Cl2, okay, those are going to combine, but what's going to swap? So we've got a non-metal here, Cl2, bromine, non-metal, metal, Na. You know it's going to be, these two are going to have a little swap. Can't speak. So it's going to end up NaCl plus Br2. Okay? Pretty straightforward. They replace the ones they're similar to.